All right, so in the last video, we were doing exponential equations and we were trying to solve some of these. Now, with an exponential equation, what you're going to want to do is take the logarithm of both sides. And I usually use the base that we start off with. So I'm taking the log base 2 of both sides. And eventually you get your answer. But what if you wanted to check your answer by graphing? How would you do that? Well, usually what I do is I go to Desmos. So I'm going to pop on over to Desmos and see what's going on. All right. So now we're here. And what I want to do is I want to start off with the original equation that they gave me. 2 to the x plus 3 power is equal to 32. So what I'm going to do is I'm going to define a new function that basically has the same uh, base as the exponential equation right here, and the exponent is going to be x plus 3. And then I'm going to set it equal to 32 and see what happens. So I need to type in 2 to the x plus 3 power. I put the exponent in parentheses, so I make sure that the x actually stays with the positive 3. And I get this graph, right? So this is my exponential equation, and I want to set it equal to 32. So I'm going to define a new function g of x, and this function is going to be equal to 32. And immediately what happens is I get a purple horizontal line that I cannot see. So what I need to do is I need to zoom out to see it, and I will see that there is a 32 right here. And what I want to know is, where do these two graphs intersect? Because that's going to be the answer to my equation. So where does the blue graph intersect with the purple graph? It's going to be right here. The ordered pair is 2, 32. So what that means is the x value is 2, the y value is 32. We're going to be using the x value when we check our solutions. So we're going to be using x equals 2 as our x value. So now I know that my answer should be 2. I go back over to my chalkboard and I see that 2 is going to be the answer for this one. So this is the x value where the two graphs intersect, where they intersect. And that is how you can check one of these equations if you ever wanted to check by graphing.